All right, guys, so this is a review for radicals. Hopefully it's a review. Some of you may be thinking you learned it. You're learning it for the first time, but you did go over this in Algebra 1. Now, whether you remember it or not, it's probably another story. But anyways, we're going to review it because we will need to know how to do this as we go into Chapter 9. Now, you did learn this in Algebra 1, like I said, but the Algebra 1 teachers are kind of divided in the way they teach it. So I'm going to show you both ways that they taught it. I have my way that I like to use, but I'm going to give you the option of using whatever way you want. Okay. So I use the prime factorization method. Okay. And the prime factorization method, it basically allows you to break this down into its prime factorization and then group it. So think of back, like in, I don't know, third grade probably, when you had the number tree. So you started with 18, and then you went to 9 and 2, and then you went to 3 and 3, and so you said 18 is 3 times 3 times 2, or 3 squared times 2. Okay, you guys did this way back in elementary school. I kind of use that, but I present it in a different way, okay? So we have 18, and a lot of people call this the ladder method or the cake method. Okay, so if we start with 18, what I want is a prime number, so all these numbers here are going to be prime numbers that, that goes into 18. Okay, so I have like 3. 3 is a prime number. Remember, prime numbers are numbers that can only be divisible by 1 and itself. So 2, 3. 4 is not, because 4 is 2 times 2. 5 is. 6 is not, because it's 2 times 3. 7 is. 8 is not. 9 is not, because it's 3 times 3. 10 is not. 11. 13. 15 is not. 17. 19. So on and so forth. These are all prime numbers. So any of these numbers that can go into here. Okay, so we said 3 can go into 18, so 18 divided by 3 gives me 6. Okay, then I want to, what prime number can go into 6? Well, 3 can again, and these can go in any order, guys. And when you do 6 divided by 3, you get 2. What prime number can go into 2? Well, 2 can. 2 divided by 2 is 1. When we get to 1, we're done. Okay, so now what I'm going to do is I'm going to go back and I'm going to circle the pairs. Okay, so I have a pair of 3s and then I have a leftover 2. Okay, this 2 doesn't have a pair to go with it. So I say pairs come out front. And then I like to think of this in terms of like dinner. And I can say leftovers go in the fridge. Okay, so when I say pairs come out front, so I'm going to bring this out front, leftovers go in the fridge, I'm going to call my square root bracket the fridge. Square root of 18 simplified completely is 3 square root of 2. This is the method that I like to use. In most of these videos, I will use this method. All right, so the other way we're going to use is the perfect square method. Okay, now the perfect square method is good if you have good math skills and if you know your perfect squares. It's also less steps than here, but I feel like you're more likely to make a mistake too. You're more likely to miss something and not simplify something completely. Okay, so the perfect square method is when we take the number inside the square root and break it down into perfect squares and then simplify it from there. So if you remember perfect squares, so like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared, 49, so on and so forth, right? Okay, so perfect squares would be your 1, and your 4, and your 9, and your 6, 25, 36, 49. Okay, and so on and so forth. There's several more. So with this method, what we're going to do is we're going to take this square root of 18 And we want to say which one of these numbers goes, is a factor of 18, I guess. We don't want to worry about 1 squared is 1 because that's a factor of everything. Okay, well, if you notice, 9 times 2 is 18. So I can change this to square root of 9 times 2, right? 18 can be written as 9 times 2. Now, what I can do is, because these are separated by a multiplication sign, this is the same thing as square root of 9 times the square root of 2. Okay? Well, the square root of 9 is 3 because 3 squared is 9. And I'm left with square root of 2. Okay? So we'd get the same answer doing it a different way. Like I said, I will do this way because this is the way I teach it. If you're comfortable doing it this way or you want to learn it doing this way, that's fine too, as long as you can show me your work. All right, so let's look at example 1 on your worksheet, okay? And example 1 is the square root of 48, okay? So I'm going to go ahead and I'm going to break 48 down, okay? Well, I know it's even, so 2 goes into 48. 48 divided by 2 is 24. Well, 2 goes into 24. 24 divided by 2 is 12. 2 goes into 12. 12 divided by 2 is 6. 2 goes into 6. 6 divided by 2 is 3. 2 doesn't go into 3. 3 goes into 3. One time when I get to 1, we're done. Okay, so once again, all these numbers are prime numbers. All right, so now I have this down to its prime factorization. Okay, so now I'm going to group the pairs. So I have a pair of 2's and a pair of 2's, and then I have this leftover 3 that doesn't have a 3 to be paired with. Okay, and if you remember, the pairs go out front, and then the leftovers go in the fridge. Okay, so pairs come out front. Here we have more than one pair. We have 2 different pairs of 2's. Okay, and when we have more than one pair, we're going to multiply them. So pairs come out front. So I have a 2 times another 2 out front. My leftover 3 goes in the radical box. And then, of course, 2 times 2 is 4, square root of 3. Okay, if you wanted to do this the other way, you'd have square root of 48, and this is where your math skills have to be pretty good. 16 times 3 is 48. Okay, so I can change this to square root of 16 times 3, because 48 is equal to 16 times 3, and then I can separate this, square root of 16 times square root of 3. My square root of 16 is 4. My square root of 3 doesn't simplify. I would get the same both ways. All right, let's look at example 12 now on your worksheet. Okay, now we have a number out in front. Okay, these aren't much different. We're just going to have one added step. So think of this as the same thing as 2 times the square root of 32. Okay, now we're just going to break 32 down like normal. Okay, so 2 goes into 32 16 times. 2 goes into 16. 16 divided by 2 is 8 times. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. When we get to 1, we are done. Okay, so pair of 2's, another pair of 2's. The pairs come out front, leftovers go in the fridge. Okay, so the pairs come out front, so I have a 2 out front and another 2 out front. Leftovers go in the fridge. So this is 4 square root of 2. So square root of 32 is the same thing as 4 square root of 2. So what I'm going to do is I'm going to come back here and I'm going to say, all right, well, this is 2 times, And I'm going to replace square root of 32 with its simplified version. 4 square root of 2. Okay? And now what I have here is I have two things that I'm going to multiply. Since this is not on the inside of the radical, I only multiply it by what's not on the inside of the radical over here. So 2 times 4 is 8, square root of 2. That is my final answer. All right, I want you to go ahead and try this one on your own. Think of this as 4 times square root of 48. And then simplify it as much as you can, and then we'll go over it. All right, so when you did this, the first thing that you should have done is you should have broken down 48. Okay, and so you got 2 pairs of 2's and then a leftover 3. So 2 times square root of 3 simplifies to 4 square root of 3. So this 4 square root of 3 is the square root of 48. Okay, but you can't forget about this 4 here in front. Okay, so I'm going to keep this 4 in front, and now I'm going to substitute 4 square root of 3 in for 48 here. And when I do that, I have to multiply the 4 times 4. I have to multiply the numbers on the outside, give me 16 square root of 3. This should be your final answer.